Dear students, today we will learn about hyperbola. In previous classes, we discussed about conic sections. In that conic sections, we learned parabola, ellipse, now hyperbola. In earlier classes, we discussed what is hyperbola, how it formed, what is the standard equation, and what are the elements of the hyperbola. Let us see some more details of the hyperbola or forms and problems here. Objectives of the today's class. On completion of this period, you would be able to find the length of latus rectum LLR of the hyperbola. Write other forms of the equation of hyperbola. Find the difference of the focal distances of the hyperbola. Define rectangular hyperbola. To find length of latus rectum of a hyperbola, that is LLR. In a short form, we say LLR. See here, the green color line indicates LL1, that is the length of latus rectum. The black color curves indicates hyperbola. Pink and blue are axis of the hyperbola, that is transverse axis and conjugate axis. C is the center 0, 0. Focus S is A, 0. And LL1 is a line segment and it is passing through the focus and perpendicular to transverse axis. Here coordinate axes are axis of the transverse axis and conjugate axis. Chord through the focus perpendicular to the transverse axis is called latus rectum. That is LL1 is called latus rectum. LS equals to Y1, that is height. Then LS equals to L1S, as the curve is symmetric about the coordinate axis. L A comma Y1 and L1 A comma minus Y1 are points on the hyperbola. L is the same distance from y-axis is A, and height from x-axis is say y1 or take y1, and L1 is also same, but it is opposite direction of the L. Equation of the hyperbola is x square minus a square by minus y square by b square equals to 1. It is given in a pink letters. That is a square e square by a square minus y1 square by b square equals to 1. Here x square, in place of x taken a, and in place of y taken y1. It is substituted because L is a point on the hyperbola. Then if we simplify, we get y1 square by b square equals to e square minus 1. The left side a square get cancelled, and minus y1 square by b square, if we got right side, it is becomes positive, and right side 1 bring to left side, it is becomes negative. So y1 square by b square equals to e square minus 1. y1 square equals to b square into e square minus 1. That equals to b square into b square by a square. That equals to b power 4 by a square. y1 equals to plus or minus b square by a. So we got ls, that is b square by a. That is LAE comma b square by a, and L1 AE comma minus b square by a. So SL equals to y1 equals to b square by a. Length of lattice rectum LLR equals to LL1, that equals to 2 into SL, that equals to 2 into b square by a. Equations of lateral recta are x equals to plus or minus a. So here length of lattice rectum equals to 2 into b square by a, and equation of lateral recta equal to x equals to plus or minus a. Rectangular hyperbola. A hyperbola is said to be a rectangular hyperbola when its transverse axis and conjugate axis are equal in length. So we have mainly two axes, and that length, if it is equal, then we say that hyperbola is a rectangular hyperbola. A hyperbola is said to be a rectangular hyperbola when its transverse axis and conjugate axis are equal in length. That means 2a equal to 2b. That means a equals to b. A equals to B, then it is called rectangular hyperbola. So both axis lengths are same. So in this case, there is no major axis and there is no minor axis. There is no big and small axis. So both are same lengths. That is, when A equal to B, the equation x square by A square minus y square by B square equals to 1 becomes x square by A square minus y square by A square equals to 1. Here in place of B we take an A because B equal to A. That is, x square minus y square equals to A square. We take LCM, we get A square as a LCM. In the numerator we have x square minus y square. The denominator, it goes to right side, it is multiplied with 1. So 1 into A square, A square. So we have x square minus y square equals to A square. Here it is given in a blue colored background. For a rectangular hyperbola, eccentricity E equals to root 2. So for a rectangular hyperbola, eccentricity E equals to root 2. So root 2 also indicates greater than 1. So it is a hyperbola, no doubt. And root 2 means, we can say, eccentricity is root 2 means that hyperbola is called rectangular hyperbola. Here it is given in a yellow color background shaded. So rectangular hyperbola means its eccentricity is root 2. If eccentricity is other than root 2, it is not said a rectangular hyperbola. It is general hyperbola. If eccentricity is equals to 1, we call it is a parabola. And less than 1, we say ellipse. And greater than 1, we say hyperbola. And 1.414, we say a rectangular hyperbola or root 2. Equation of the hyperbola with center at C h comma k and transverse axis parallel to x-axis. In the first form, we take an center as a 0, 0 and transverse axis along x-axis. Here, transverse axis is parallel to x-axis and center is moved from 0, 0 to h comma k. Then the equation is x minus h whole square by a square minus y minus k whole square by b square equals to 1. Here x minus h and y minus k should be kept in a bracket. Brackets are here missing. We should keep them in a bracket. And here the equation given in a pink color. And see the diagram, x-axis and y-axis, and hyperbola given in a black colored curves in black ink. and pink color is a axis, that is transverse axis of the hyperbola, and it is parallel to x-axis, and blue color line given, it is parallel to y-axis, and in green color center C H comma K given, and focus given, and say yes. So this hyperbola equation is x minus h whole square by a square minus y minus k whole square by b square equals to 1. For the hyperbola, x minus h whole square by a square minus y minus k whole square by b square equals to 1. Center h comma k, it is at C. Transverse axis is parallel to x-axis. Vertices at A, h plus or minus a comma k. So the transverse axis where it cuts the hyperbola, and at that intersect points we say A1. The right side we say A, that is h plus or minus a comma k. So k indicates height and h plus a indicates the distance from origin to vertex A. 4C at S h plus or minus a comma k. Here vertices and 4C combinedly we said, so two vertex plus or minus a, plus is one vertex, minus means another vertex. The same way focus, h plus or minus a plus ae one focus, minus ae another side focus. So h plus or minus a comma k. Equations of directrices are x equals to h plus or minus a by e. Equations of lateral recta are x equals to h plus or minus a, or a into e. Here equations are also given, plus or minus means one is right side, another one is left side from the center. Equation of transverse axis is y equals to k. Equation of conjugate axis is x equals to h. So conjugate axis is x equals to h. That means it is located from the y-axis to in the h distance on x-axis. Length of latus rectum, that is LLR, equals to 2b square by a, or 2 into b square by a. We already proved this length of latus rectum. Equation of the hyperbola with center at C, h comma k, and transverse axis parallel to y-axis is y minus k whole square by a square minus x minus h whole square by b square equals to 1. The pink colored letters are indicated the equation of the hyperbola with the center h comma k and transverse axis parallel to y axis. So here in the numerator, x terms will be replaced with y terms and y terms are replaced with the x terms compared to the before equation we learned, that is parallel to x axis. Here transverse axis parallel to y axis, so axes are changed means, so the in place of x minus h we see y minus k, and in place of y minus k we see x minus h. So xy are here interchanged, that is the main difference we can see. Same here, brackets are missing, so you have to kept y minus k and x minus h in the bracket. See, diagram is now showing like vertically. So the hyperbola is now we say vertically it is appearing, or hyperbola is on transverse axis which is parallel to y axis. Here black colored curves showing hyperbola and pink color is showing its transverse axis parallel to y axis, and blue color line is indicating conjugate axis and it is parallel to x axis. Focus yes and center C h comma k given. For the hyperbola, y minus k whole square by a square x minus h whole square by b square equals to 1. Y minus k and x minus h should be kept in a bracket. Center at C h comma k, transverse axis parallel to y axis, vertices at a h comma k plus r minus a, foci at s h comma k plus r minus a. Here plus r minus means plus is right side of the center and or upward of the center, and minus is downward of the center for vertex and focus. The same way, equations of directrices are y equal to k plus r minus a by e. Plus means upward and minus means downward. So two directrix are combinedly given. The same way, equations of lateral recta are y equal to k plus r minus ae. So plus is upward side and minus is the downward side from the center. So equation of lateral recta are y equal to k plus or minus e. Equation of transverse axis is x equals to h. Equation of conjugate axis is y equals to k. Length of latus rectum equals to 2 into b square by a. See here, center and length of latus rectum are unchanged in previous form and in this form, that is third and fourth form. Remaining a little bit preferences changed from x-axis to y-axis or x to y. Equation of the hyperbola with focus S x1 comma y1, directrix as ax plus by plus c equals to 0, and eccentricity E is given by x minus x1 whole square plus y minus y1 whole square equals to e square into ax plus by plus c by under root a square plus b square whole square. You can see it in a pink color letters. So here for x minus x1 and y minus y1, the brackets are missing. We have to kept in a bracket. This is very important and simple formula, and this is a common formula for both the parabola, ellipse and hyperbola. For 3 conic sections, if the data given like focus, directrix and eccentricity, then the equation of that particular conic section, that is either it is ellipse or parabola or hyperbola, the formula is same. So please note down and write 10 times so that you can remember easily. Very simple, and it is we know how it came. It is based on eccentricity condition, or SP by PM equals to E. So SP square equals to E square into PM square. That is we are expressed it in an equation. So write 10 times and memorize the formula. Next, the difference of focal distances of any point on the hyperbola is equal to its transverse axis, that is constant, that is S1p minus SP equals to 2a. See here, the difference of focal distance of any point on the hyperbola is equals to its transverse axis, that is constant. So S1p minus SP equals to 2a. S1 are foci, P is a point on the hyperbola, and 2a is the length of transverse axis. See here, we can observe the S1p and SP. Here, see the focus S and another focus S1, and P is in a green color point given x1, x comma y, px comma y, and SP and S1P are given in a light blue color or near to black color. We can say SP and S1P are given, and S1P minus SP we can say 2A. So in the diagram we can see S1P is bigger than SP, so that difference is equal to length of transverse axis means A to A1, that is 2A. So here two directrix are taken in a green color, M1, and pink color line, that is a transverse axis, and small pink color line is perpendicular distance from P to M and M1, and blue color line is indicating conjugate axis. C is the center, Z1 are directrix, and A1 are vertices, B1 are the conjugate axis points or vertices. Here XY axis or coordinate axis or axis of the hyperbolas, transverse and conjugate axis. Let P x comma y be any point on the hyperbola, C be the center of the hyperbola, S and S1 be the foci of the hyperbola, ZM comma Z1 M1 be the directrices of the hyperbola, A1 and B1 be the vertices on the transverse and conjugate axis respectively. PM1 be the perpendicular distances on ZM comma Z1 M1 respectively. By the definition of the conic, SP by PM equals to E, then SP equals to E into PM. Consider it as equation 1. Similarly, S1P by PM1 equals to E. Then S1P equals to E into PM1. Consider it equation as 2. From 1 and 2, S1P minus SP equals to E into PM1 minus E into PM. It means we subtracted, so left side terms subtracted to left side and right side terms subtracted and written right side. That equals to E into M1, that equals to E into 2A by E, distance between directrices. So E get cancelled, we get 2a. So S1p minus SP equals to 2a. That is indicates the length of transverse axis is equals to differences of the focal lengths from point P. So summary. For a hyperbola, length of lateral rectum is 2b square by a. Center C is the midpoint of the foci SS1, vertices AA1, directrices ZZ1. For a rectangular hyperbola, eccentricity is root 2 and a equal to b, which length of latus rectum of the hyperbola is, here options are given: a 2a square by b, b 2b square by a, c a square by b. So answer is b, that is 2b square by a. It is here indicated in a red color. We already proved that, and we already know length of latus rectum is 2b square by a. Difference of the focal distances of a hyperbola is, so this difference of the focal distances of a hyperbola is, the focal distances the hyperbola is 2a, option A 2a, option B 2b, option C none. This is also will new in just now. We already learnt that is 2a. Focal distances means S1p minus SP. So this is the hyperbola's elements. It is the length of latus rectum or latus rectum, and eccentricity is root 2, then we call it is a rectangular hyperbola. See, in a rectangular, opposite sides are equal. And if here A and B are equal, it may looks like rectangle. Or if axis lengths are equal, then its eccentricity is becomes root 2. So in these two cases, we say it is a, or it will be called rectangular hyperbola. So in the exam, without giving eccentricity, he can say, or he can give the name, or he can give the question as a rectangular hyperbola. So rectangular hyperbola means we have to understand its eccentricity is root 2. If we only mentioned hyperbola, then we have to find eccentricity, and we have to know, or we have to find from given data or given conditions. But whenever if he says rectangular hyperbola, that means eccentricity is included or given. The eccentricity is root 2. And here we discussed the third and fourth form of the hyperbola. First two forms are we already know, and its center is 0, 0, and its axes are coordinate axis. But now here we learned third and fourth form, which are similar to first and second form. So in the first form, we have the equation x square by a square minus y square by b square equals to 1. Whereas in the third form, we can say x minus h whole square by a square minus y minus k whole square by b square equals to 1. And fourth form is a little bit different. Y minus k whole square by a square minus x minus h whole square by b square equals to 1. So third, fourth forms are same, but the difference is x, y are interchanged, and diagram also interchanges from horizontal to vertical. And it is like ellipse. Ellipse also 4 forms. First two forms are with center 0, 0, and another 2 forms are with center h, k. In the same way, hyperbola also with 0, 0, 2 forms, that is center, and h, k center is also having 2 forms. So total hyperbola contains 4 forms majorly. And this is an open curve, and ellipse is a closed curve. Ellipse eccentricity is less than 1, and hyperbola eccentricity is greater than 1. And if eccentricity is root 2, we can call, or we can say, it is a rectangular hyperbola. When focus, directrix, and eccentricity is given, then the equation of the hyperbola is x minus x1 whole square plus y minus y1 whole square equals to e square into ax plus by plus c by under root of a square plus b square whole square. So this equation is useful for in 3 conic sections, that is parabola, ellipse, and hyperbola. The three, if the data is given like focus, directrix, eccentricity, so it is useful for to find three equations. So this formula is common for three chapters on three conic sections. For parabola, eccentricity is 1, so we sometimes need not to write E and E value. Whereas ellipse and hyperbola we have to mention because less than 1 is ellipse. That means it may be 0.2 or 0.3 or 0.5, whatever, it is all less than 1. So there are so many numbers. The same way, greater than 1 also we have so many numbers, that is 1.1, 2, 3, 4. So that's why we have to write E for ellipse and hyperbola. For parabola we need not to write its eccentricity E or its value. And focal distances, here we are the difference is equals to transverse axis, so that is SP and S1P. These are focal distances, so S1P minus SP and S1P are focal lengths, and the distance or focal distance also, length or distance is same, and that difference, okay, focal distance equals to focal length, but the difference of the focal lengths or focal distances is S1P minus SP. It is equals to length of transverse axis, that is 2a. So this is the point we already know, and length of lateral rectum is 2b square by a. So this is about hyperbola and its forms and its elements. So on this chapter, from exercise you have to do problems, and if you have any doubts you can ask me, and you can message me on my WhatsApp. We will discuss in next class, and we do some more problems on this. Have a great day. Thank you.